You do that in like, because it's also about.
Well, okay. So the point is, people understand chicken McNugget theorem because it's like chicken McNuggets, but this is like Bezoos and who the fuck
Or
knows?
theorem. It's like you probably already know it.
Let's say you had a overly simplified version of football where each field goal was worth 3 points. And each.
Alright, this time it's your fault, Reese.
And then for Dina, it's just one side. Just watch the
Why is there half of a question mark?
fairly quickly.
So, let's say we have an overly simplified version of football where each field goal is worth 3 points and each touchdown is worth 7 points. And there are no other ways to score points, and time is not an issue. What is the greatest number of points that can't be scored? Well, here is a cool trick you can use to solve this problem and impress your friends. It's called the Chicken McNugget theorem. It basically states that if you have two numbers m and n, the greatest number that can't be made with quantities of m and n is mn minus m minus n. So then basically the solution to our problem is 3 times 7 minus 3 minus 7, which is 21 minus 3 minus 7, which is equal to 11.
But what if you have 3 numbers?
That is a topic for another video. So the next time that you order chicken McNuggets at McDonald's, you can use the chicken McNugget theorem to find out the greatest number of chicken nuggets that you can order.
How should I begin? Like, hello, my fellow men, women, men and women, boys and girls. Today I'm going to be presenting you a very cool math trick, and it involves multiplication by 11. And you can show this to your friends, and they'll be like, wow, I'm so impressed that you were able to compute this that quickly in your head. And then you'll show them this trick, and maybe they'll show their friends as well. So, say that we have a single digit number and it's a. Then we can multiply a by 11. And I think everybody here knows that when you multiply a single digit number by 11, you get a number like a. For example, 3 times 11 is equal to 33. If you have a 2-digit number, say that it's AB, and you multiply that by 11, you can get a result that is, the first digit is A, the second digit is A plus B, and the third digit is B. So for example, 37 times 11 is equal to 3. 3 plus 7 is 10, and the last digit would be 7. Now, since we have a 10, we're going to have to carry over the 1 to make this a 4, and we get 407. The same thing applies with 3-digit numbers, and so on. So, whenever A plus B or B plus C is greater than 9, then we can actually shift it over to the next digit. So, for example, like 364 times 11, this would be 3, 9, and then we have a 10 here, and the last digit is a 4. So we can shift this over to make this 40, and then we add the 04 at the end. So yeah, that's the trick that I wanted you to show you guys. So I hope you like this presentation and show this to your friends because it's really awesome. Thanks for watching.
Okay. So the question we're going to be asking ourselves today is, how many people do there need to be in a room so that there's over a 50% chance that 2 of them will have the same birthday? And at first glance, since there are 366 birthdays, it seems like there are going to need to be a lot of people. But actually, that's not true. In fact, you only need 23 people to be in the room for there to be a 50% chance.
You need there's 23 people in this room.
So let's start with a calculation to show that this is true. So the way we do this is first by seeing the probability that none of them have the same birthday. And the opposite of that is that at least 2 of them have the same birthday. So we find the probability that none of them have the same birthday, then we can just take 1 minus that probability. So if there are 23 people, for the first person, regardless of who they are, it's impossible for them to share a birthday with someone because there's only one person in the room. Now let's say a second person enters. For this person to not have the same birthday as this person, they're limited to all of the 365 options that aren't including this person's birthday. Now let's say a third person enters. Then this person is limited to the 364 birthdays that are not these 2 people's birthdays. So you keep multiplying in this fashion, and by the 23rd person, you should have 344 out of 366. So if you multiply all of this together, it turns out that this is around 49.3%. So 1 minus this probability is around 50.7%. So this means that if you have 23 people, there's a greater than 50% chance that 2 of them have the same birthday. Good. Thanks to the overcrowded West High hallways, what you can do is see if there are 2 people in your class that have the same birthday, because I can pretty much guarantee you that more than 50% of the classes at West High have more than 23 people. So ask everyone for their birthdays, and then see if there are 2 people with the same birthday.
If it's their birthday that day, give them a hug.
Yeah.
Today we'll be learning about how Bush did 9/11. So, melting point of steel. 1510 degrees Fahrenheit. Jet fuel temperature. Boiling point, 176. That is significantly less. Therefore, jet fuel came out steel beams. Bush did 9/11.